Hello, Mr. Lesham is here and we are starting a new chapter. Okay, we are in chapter 2, functions and inverse function. Okay, right, I'm going to take you back. I'm going to take you back to prep school. Okay, you remember number sense?
Nope.
Number sense, yes. Okay, do you remember you used to have things like this? Okay, it wasn't written 2x plus 1, but it used to be written, I'll write maybe, if I had green, I would write green, I'll write black, time 2 plus 1, I think something like that. Or time 2 add 1, I'm not sure how. Remember, you have a bunch of numbers, spider, and what do you call them? Spider diagram. Yeah? You have different input and you have to figure out the output. Okay? So maybe I will write more in like grade 8. So we basically, what are we doing to these numbers? We're timing them by 2 and adding 1. Okay? So if I put in this machine 0, what would I get? 1. Okay? 2 times 0 plus 1 is 1. Okay? Yeah, exactly. The x value, these are the x values. These are basically the x value, these are like the y values. Okay? Right? If I put in 1, what do I get? 3. Okay? Okay? If I put in 2, I get 5. Okay? So when I teach function in the beginning, grade 8 and grade 9, I say that function is like a machine. It's a machine. You put an input and it gets an output. Just like we have different machines, we've got different functions. You can put the same input in one function, you'll get different output compared to the other. Okay? A machine, I used to call it like eat, or you turn in the number, you put in 0, or 1 goes up. You put in 1, eat, 3 comes up. Okay? Right, okay. So far, so good. What we're going to do now for the first time, we're going to talk about a specific machine. Each function, if this is a function, what I'm trying to find is the inverse function. What does the inverse function mean? What do you think? Let's see, maybe you can guess. So Finn got it, let me just explain. Every function, if this is a function, okay, I'll call it the function, will have an inverse function where it basically works in reverse. So it is kind of what you said, Eugene. Okay? So in other words, if I put a 1 as my x, I'm going to get a 0. If I put a 3, which was the output here, I'm going to get back my 1. If I put my 5 here, I'm going to get back my 2. Okay? That's called the inverse function. Okay? And if the function we write is f of x, listen to this, the inverse function is f minus 1 of x. It's not f to the power of minus 1. I know it looks like it, but it's not f to the power of minus. It just means it's the inverse function. I'll pause for a question. Yes. So, if we're looking at a specific question, 2x, a specific function, 2x plus 1, my question mark here means that I want to find out what is the inverse function. And now that sort of stuff, question like that, you didn't call it inverse function, but you did do it in prep, I think, definitely in grade 8. Where I'm giving you inputs and you're getting output, we need to find out what to do. So can we try and think, if this is the rule for the function, what's going to be the rule for this inverse function? I'll give you a minute to think about it. So Jason got 100% right, and I think the way he thought about it, he said, okay, so you said here, you first you multiply by the 2, and then you add a 1. So the way to work, if we're working in reverse now, this is an inverse function, then first of all, we're going to minus the 1 first, minus 1, and then divide, okay, after you minus 1, you divide by 2. So we're working everything in reverse, okay? So writing it in this form is going to be, first of all, if I start with x, I'm going to do minus 1. And only then I'm going to divide by 2. Okay? Let's see if that works, first of all. 1, if I put 1, what do I get here? 1 minus 1 over 2 is? 0. 3 minus 1 over 2? 1. 5 minus 1 over 2? It's 2. It works. Now, all he's asking, is this the only way of doing it? Is there an easier way? 100% there's an easy way. I'm going to show you now. Okay? So the way to do it is we start with a function, okay? Now, sometime it will say f of x equal 2x plus 1, okay? Sometime you'll have a function written like that. That is exactly the same, equivalent. This sign is equivalent. It's exactly the same as writing y equal to x plus 1, right? Okay? So, what I want to do is find a new function. This is the f of x. I want to find out what's the inverse of x. What's that equal to? Well, I know what it is. I know it's x minus 1 plus 2. But I want to know how to get it. Okay? Right. So I'm going to do it in 2 stages. First step, I'll write it down. First step, step 1. Step 1, swap x and y. Just swap it. Just swap it. Okay? So wherever I have, so this is the first step. Okay, I'll just write it. Yeah, step 1. Step 1. So wherever I have y, I write an x. X equal 2. Instead of x, I'm going to write a y. Okay? That's step 1. Step 2. What do you reckon I need to do now? I want to know what y is, isn't it? So how would I isolate y? In other words, solve for x. For y. We want to find what y is equal. It's already solved for x. I know what x is. Now I want to know what y is. So step 2. Solve for y. Okay? So we're going to write that. Okay, how do I find that? First of all, first step, I'm going to minus the 1. Okay? I'm just minusing the 1. Okay? So x equal to x minus 1 equal to y. You know what I mean when I say solve for y? Find out what y is equal. Okay? So I move them 1 to the other side. Now I'm going to, what am I going to do now? No substitute. What do I need to do? You divide by 2. Thank you. So I'm going to divide by 2. I'm going to have y equal x minus 1 over 2, which is what I wanted to find out. Okay? So I started with the function, and eventually I got the inverse function. You can either leave it as y equal x minus 1 over 2, or you can write down f of the f minus 1 of x, the inverse function is x minus 1 over 2. Okay? I know it's a little bit hazy. We're going to do another example. Guys, let's do a couple more examples. The first one, y equal x over 2 minus 3. We want to find the inverse function. Okay? So what's the first step to do? Swap. Just not thinking, just swapping. Okay, x equal y over 2 minus 3. That's step 1. Done. Okay, you got a mark. Next thing, what do I do now? Solve for y. Because I need to end up with y equals something. That's how functions are. We write y equals something. So what will be the first step here? Right. Plus 3. So I'm going to write y over 2 equal x plus 3. And then finally, times by 2. 2x plus 6. Okay? Now if you want, if you're a little bit bored this weekend, you can draw a spider diagram for y equal x over 2 minus 3, get some outputs, put the output in as an input, you see you get the same. Okay? Okay? Let's do one more. Okay, I'll just pause for you. Another one, and here there is a little bit of an issue. So just, yeah, we're going to add something new. Y equal 3x squared. Step 1, what should I do? Swap. X equal 3y squared. Okay, and then we want to solve for y. So what we're going to do now? Okay, so y squared equal x over 3, and then square root it. Y equal square root x over 3. Are we happy with that? Yeah. Okay, we've got a little bit of an issue. Okay, so let's see just what happens if I just want to get a nice, neat number. Hang on. I mean, first of all, is this alright? Okay, yeah. Oh, yeah, okay. That's a little bit weird. Just a second. Just pause a second. Hey, chaps, so this is not incorrect, it's correct. It's truth, but it's not the whole truth. There's a little bit more. Okay. And to understand that, I did draw these spider diagrams. That's the function, that's the inverse function. And I want to look at a specific input, 1. When the input here is 1 in the function, what will be the output? 3. It will be 3, right? 3 times 1 squared. So if I put a 3 here, what should I get on the outside? 1, which it works, right? Because I put 3 over 3 is 1 square root of 1, 1. It's fine. No, leave the 4. But I want to give another input. Okay, sorry, let me write it like this. 3. What if I put in minus 1? What happens if I put minus 1 here? Nothing. Is it minus 3? What is 3 times minus 1 squared? 3 times minus 1 squared. How much is that?
3.
It's still 3 because the square took that minus and annihilated. So whether you put 1 or minus 1, your output is 3, right?
Yeah.
Okay? But if this is a true inverse function, if I put a 3, I should get 1 or minus 1. Right? So, you know, because I got 2 inputs give me the same output, if I put an input, I should get 2 inputs, 2 outputs. Yeah. Okay? So what we're going to do is, we got to add something here. If y equals square root x over 3 or, say it a bit louder, plus minus. I have to write plus minus. There's 2 options. It's either going to be 1 or minus 1.
I'll leave it a square.
Okay? Square root of that, okay? Only when it's a square then you'll get that. It's only when you have a square here, you're right. But, my friends, okay? This thing, when you have that plus minus, then we say that it's not really a function, okay? It's not a function. And that is an important thing to be aware of. And I just want to use it's not a function. They say we're going to learn about it later, so I'm going to keep you on we're not going to say too much. But I can already say now that a function, it's okay to have 2 different inputs that will give you the same output. But if you have 1 input giving 2 outputs, that's not really a function. Because a function means you put an x, you get a y. Now you're telling me I get 2 y's. Which one do I choose? Okay? So this is a mathematical thing that we are allowed to write it, but that means it's not a function. Okay? Right, I can't hold myself, so I'm going to actually do something more about this. Okay? If I draw y equal 3x squared, and I draw a graph of this, what would that look like? You know how to draw these graphs. What kind of graph is this? What do we call that graph?
Mathematical graph.
No, come on guys. Start with a P.
Which one's parabola?
Parabola, okay? It looks like this. It's a smiley face, right? Right? And you can see, by the way, that for the same y, in this case the y was 3, I'm going to have two x's, right? Minus 1 and plus 1. Okay? That's this thing. You have 2 inputs give you the same output. Now, if I was to draw this is a square root graph, without getting into too much detail, it's going to look like that. It's like a parabola that turns sideways. Okay? Never mind that, and you don't need to really know it, but you can already see that for the same x, if I choose x, what is it? X equals 3, I'm going to have 2 y's, right? Minus 1 and plus 1. Okay? Now, this is a function. This is not a function. I cannot have 2 different y's for the same x, okay? Right. I'll pause here, see if there's anything else we need to do. The next kind of function is where exponents. So we did the square, we did the linear, now we have the x. You know, it's not x to the power 5. I won't call that an exponent, that's just x to the power 5. When I have the x as the power, we call those exponents. And I'm giving you this function, and I want to find out the inverse function. I deliberately don't write the y now, because sometime in the test that might be the way we write. We write, given f of x equals 5 of x, 5 power x, find f minus 1x. It's not 5 to the power minus 1. Don't write down, oh, that's 5 to the power x minus 1 equals 5 to the power minus 6. No, it's not f to the power, it's the inverse function. Now, what I suggest you do, in fact, I'll tell you to do, first of all, convert this into y. So write just y equals 5 to the power of x. We can call that step 0 if you want. Okay, step 0. Just come up with that now. Step 0, convert f of x to y. Instead of writing f of x, write y. It's just easier. Okay? Right, so that was step 0. Step 1. What will step 1 be? Swap. X equals
I don't know what you're saying now. So
5 to the power.
You just proved both of the stuff.
Sorry?
You just proved both of the stuff. So y equals to 5x and x equals to 5.
Yes, but I don't want to find out what I don't want to find what x is. Step 2 is solve for y.
We already have y. Y is equal to 5x.
But now I want to find the inverse function.
No.
Okay, remember, so we do that swap, we're kind of forcing us to do that. I didn't really get into why we're doing it. Let's just keep it simple. So the first step, swap x and y, and now solve for y. Okay, how do I find what y is equal to?
Log.
Well done, Ali. Okay, so using roots or powers or multiply or adding, you will never be able to figure out what the y is. There's only one way of doing it, and that's the log. And that's what the log is defined for. So I'm going to write a log here. And what should I write now? See if you remember.
5.
5 is the base in here.
Y.
No, y is here. The
Oh,
x. Okay? So that is the inverse function. And then I want to convert it back to f of minus x, because I will ask you to write down the inverse function. Again, we can call it step, I don't know, step 4, step 3, or step 3. Change the y into f minus x. Okay? So it's going to be f of minus x equal log x base 5. That's the answer. Okay? Pause that to sync. We're going to do something similar, but now with the negative exponent. Let's see what happens. Okay, so the step 0, we said we just, instead of f of x, we're going to write y equal 3 to the power minus 6. What shall we do now? Step 1.
Should swap x.
Swap. So in other words, I'm going to write x equal 3 to the power minus y. Okay. Step 2. I have to log it. Okay. So, okay, I'm going to write a log here. Before I deal with the log, what will I have on the left side? This is where it's a little bit tricky. Is it just a y? It's minus y, because the exponent, here I have to write the exponent. The exponent is minus y, so I've got to write minus y. We'll get rid of that minus in a second. Okay? Right, log what?
3.
Log x base 3. And then because we want to find out what y is equal, we're going to say y is equal to, how do I get rid of that minus? This is not difficult. That's it. Negative log x base 3. And that is the answer, right? If you want to write in terms of f minus 1 of x is minus log x base 3. Okay, I'll pause here. We'll do maybe a couple more. H of x, sometimes we use h or g, equal minus 4 to the power of x. We want to find h minus 1 of x. Okay, first step, write down y equal minus 4 to the power of x. Next step, swap x equal minus 4 to the power of y. Now I've got to use the log. Okay, so y equal to?
Log minus 4.
Okay, now we have a little bit of a problem, don't we? Okay, log to the, what is it, minus 4 base x, right? So we're in trouble.
Massive trouble.
Why are we in trouble?
Should be a negative.
We can't have negative bases. Did we talk about that?
Yeah.
I think we did. Okay, so I can't have negative base. Alright, so I gotta do one more thing before I go over that. How do I get rid of that minus? Times it by minus 1, right? So then what will I write?
Minus x.
Minus x equal 4 to the power of y. And now it's going to work because now I've got a positive base. So your base has to be positive. If that means shifting the minus to the other side, so be it. It's okay. Now I'm going to write down y equal to log what? What? The base is 4 and what's inside?
X.
Minus 6. It has a negative, so I have to put. This thing is inside the log. And that's fine. That can't, well, you might say, hang on, shouldn't I have this thing has to be positive. We did say whatever in the log has to be positive. That means that the x's that we are allowing are only negative x's. So negative times negative will be positive. Okay? Remember, I'll try and explain again. I'll just pause. We don't need it in the video. Guys, come. Two last problems. Now, I've got a function. It's a log function. And I want to find out the inverse of the log. So, if the inverse of exponent is a log, what do you think will be the inverse of a log? Exponent, you're right. If the inverse of exponent, you end up with a log, that means it makes sense. The inverse of log will be an exponent. And you're right, and let's try and do it. So the first step, we just swap it. So x equal log y base 5. And now you had to use just like we did before. How do I find what the y is? How do I know what the y is if it's in the log? How do I get it out of the log?
So we know 5 is the base.
5 is still the base. It was the base here, and it will be the base there.
So it's 5 to the power of
5 to the power
of x. Oh.
Okay? Guys, the rule here that really needs to be in your head is this. I'll write it down. If y equal log x base 8, okay? If this is the case, let's say you have this equation. That means that x is going to be equal to what? If y equal to the a base a power y. This needs to be drilled in your head. This is how you move from log to exponent. It is a bit crazy. What we understand now better is that log and exponent are inverse functions. Okay? Maybe we'll do one last one and that's it for this week. So g of x equal log the base 3 minus x. Okay, so I've got a function g of x equal the log base 3 of minus x. I want to find out what is g minus x. What's the inverse of g? So first of all, let's change the g. Remember, step 0 into y. So we're going to write down y equal log base 3 minus x. That's step 1 or step 0. Step 1 is
x.
Swap. Okay? So instead of y, I'm going to write x. X log 3. Instead of minus x, I'm going to write minus y. That's step 1. Step 2, solve for y, right? So, well, I don't have y, I have minus y. So I'm going to write minus y equal to what? This is the tricky part. 3 to the power? Fantasticos. And then I haven't solved for y. I have solved for minus y. So I'll get rid of the minus and I'll have y equal. And just to be on the safe side, so we don't pick and take off a mark, then write it down in terms of g minus 1. So g minus 1 of x equal minus 3 to the power of x. Okay, I'll just see that we got it right. We got it right. Have a lovely, lovely weekend.